this video we're going to go over solving second order ordinary differential equations using Laplace transforms. So here we've got the proof of the Laplace transform of the second derivative here. It uses integration by parts. In the previous video solving first order ordinary differential equations, we went over the proof of the Laplace transform of the first derivative. So we'll be using that in the example later. So following the math, we come out with a solution for the Laplace transform of the second derivative. It gives us the first derivative plus s multiplied by the function plus s squared multiplied by the Laplace transform of the function. So if we move on to the example, we'll be using this. We have the second derivative of the function minus 5 multiplied by the first derivative plus 6 multiplied by the function equals 5 cosine 40, and we're given the initial conditions here. So the first thing we're going to do is find the Laplace transforms of everything in this function. So the Laplace transforms of the second derivative we have up here. So we have s dt so that's the first one, minus 5. Now in the previous video we went over the proof of the Laplace transform of the first derivative, and that was equal to s minus f plus 6, and then the Laplace transform. Now the Laplace transform of 5 cosine 40 we get from tables. So 5 cosine 40, 5s over s squared plus 16, because we have 4 here, so 16. So now we're going to add the Laplace transform of the derivative, which we forgot. So now we're going to substitute in these values because we were given the initial conditions of the function on the first derivative, and they're both equal to 0. So this term 0, this term 0, this term 0, and that's it. So we can cancel out some through the initial conditions. So we're left with s squared, the Laplace transform, minus 5s of the Laplace transform, plus 6 multiplied by the Laplace transform, equals 5s over s squared plus 16. So now we can factorise on this left hand side. So we're left with the Laplace transform multiplied by s squared minus 5s plus 6 equals 5s over s squared plus 16. Then we're going to divide here. So now we're going to move on to the next page and factorise. So I'll just write out the previous work. Squared, I think it was minus 5s plus 6. So now that we've got that, we need to separate into partial fractions. We could use partial fractions, but before we try and do that, because that's a bit more exhaustive, we're going to try and factorise. So can't factorise this one. S squared minus 5s plus 6. I think we can factorise that. S minus 3 multiplied by S minus 2. Yep. So square plus 16, S minus 2, S minus 3. Yep, that works out. So now that we've got this, we need to actually separate it out. So the 5s, S squared plus 16, S minus 2 and S minus 3, that would equal to A squared plus 16, we would have AS plus B actually, because we have S squared, plus C over S minus 2 plus D over S minus 3. So now that we've done that, we're going to multiply and form an equation. So we have AS multiplied by S minus 2 and S minus 3. We have B multiplied by S minus 2 and S minus 3. And then we have C multiplied by S squared plus 16 and S minus 3. Plus D multiplied by S squared plus 16 and S minus 2, and that equals 5s. So now that we've formed this long equation, we can substitute in values for s to generate 4 simultaneous equations. Then we can solve them using the calculator or other means and find the values for A, B, C and D. So if substituting S equals 4, 5, 6 and 7, we'll get 4 simultaneous equations. So if we write down A, just so it's easier to input our numbers, B, C and D. So if we substitute in 4 to these equations in terms of S, for A we will get 2. If we put the 4, we'd have 2, 4 here would have 1, 2 multiplied by this is 8. So we have 8 here. And then we'd substitute in 4 for this term to find the coefficient for B. So it'd be 2 multiplied by 1, it would just be B. 2B, sorry. And then for the C term, we'd substitute in 4 to get us, so we have this 32. And then for D, we would have so 64. So, yep, so we would do that for 4, 5, 6 and 7 for all of these numbers. So I've already done that on a separate sheet just because it would take a very long time and I don't want this video to go on forever. So I'm just going to fill in the numbers. So you have 30, 72, 140 for A. For B we have 2, 6, 12 and 20. For C we have 32, 82, 156 and 260. For D we have 64, 123, 208 and 325. And then we have 20, 25, 30 and 35. So now once we've generated our simultaneous equations, we're going to use our calculator to solve them So we have 4 unknowns. So if we just input in these values, we should be generated with values for A, B, C and D. So for A we have negative 0.1, B we have negative 0.8, C negative 0.5 and D is 0.6. So now that we've got that, we can put them in as our partial fractions. So 5s over s squared plus 16 if s minus 2 and s minus 3 were our fractions. So now that we've got that, if we put in our values for A, B, C and D, we have A is minus 1 over 10 is this equivalent to 0.1. So minus 1 over 10 s squared plus 16. And then for B we have negative 0.8. So we have negative 8 over 10 s squared plus 16. Sorry for this one, we forgot the s, because it's negative 1 over 10, but as remembered we had a s plus b. So then for C it'd be negative 1 over 2 s minus 2, and then for D we have plus 6 over 10 s minus 3. So now that we've got our partial fractions, we can find the inverse of the Laplace transform, because right now it's the Laplace. So our function, we'll be using the tables again. So finding the inverse of this one, negative 5 over 10. This can be, negative 1 over 10, and we have s on top. So if we look at what we have, I think it's this one, cosine. Because we have s on top, we have an s squared plus w squared, which is 4. So we could have negative 0.1 cosine, and then that 16 is the w squared. So it will be 40. Then we have negative, we can pull 8 over 10, so 0.8. We can pull that off, so we have 1 over s squared plus 16. So I'm thinking that will be sine, because we would have a number here. But because we have, it would have a 4 on the bottom, because 4 squared is 16, it would also have a 4 on the top. So we would have to divide our 0.8 by 4 to get the correct coefficient. So we have 0.8 divided by 4, 0.2. So it would be negative 0.2, and then we would have 4 as w, sine 40. And then for this next one, negative a half, 1 over s minus 2, so here, negative 0.5 e to the 2t. And then for the last one, plus, this is the exact same one, because it's s minus, so we have 0.6 e to the 3t. And that'll be the function that we've just solved. And that's how you solve secondary order differential equations using Laplace transforms.